In this video, we will learn how to write an assembly language program to divide 16-bit number by 16-bit number. In the previous video, we have already learned how to write an program to divide 8-bit by 8-bit number and 16-bit by 8-bit number. So in this video, we will learn how we can divide the number by 16-bit by 16-bit. So here in this program, we have to take these two numbers as number 1 and number 2 as the 16-bit number. For declaration of 16-bit number, we require this DW directive, that is define word. So define word is used for declaration of the 16-bit number, and we are declaring this variable in our data segment. So we are writing here dot data for declaration of our variable. The first line of our code is dot model small. So why we are writing this dot model small? Because our all data and our all code, these are the two segments that are stored within only one program segment, and dot model small is called as a memory model. So here we have done the declaration of variable in our data segment, and in this code segment we are writing the actual code of our program. And here our program ends with the help of end of the program, and here we are ending our program code segment as well as our data segment. Now you can check that what is the next line of our dot code. In that we are writing here move ax at the rate data and move ds comma ax. With the help of these two lines, we are starting the execution of our program, and we are initializing the data segment in our code segment. So whatever the variable that are written inside the data segment, that can be accessed within our code segment. Now these three lines indicates that we are clearing our AX register, BX register, and next one is DX register. So the value of AX, BX, and DX becomes 0000H. So here we can write it as AX is equal to 00, then BX is equal to 00, and our dx is equal to also 0000H. So now we have said this ax, bx, and ds is equal to 0000H. Now for performing the division of 16-bit by 16-bit number, we have to copy the contents of number 1 and number 2 in one of the 16-bit register. So we are copying these contents of number 2 into our AX register after writing the statement move AX comma number 1. So whenever we are writing this statement, the values of AX will be updated and it will become 4445. So we are writing here 44 in our AH register and 45 in our AL register. So now our AX becomes 4445. Now the next statement is move BX comma number 2. So the contents of number 2 is 1000H, that is 1000H. So we are copying the contents of number 2 into our BX register. So BX value will be updated with our 1000. So now our AX consists of 4445 and our BX consists of 1000. So these are the two hexadecimal values we have stored in our AX and BX register. So now what is the next instruction? That is division BX. So whenever we are writing this instruction, that is division BX, that time we have to check first of all what is the source operand. So here the source operand is BX register. So this is the operation for your division instruction. So the first operation is if the source is byte, and the second operation is if the source is word. So here in this example, in this program, this second condition is satisfied. That is if source is word. So we have to check these two operations, that is how the quotient and remainder will be stored in that variable. So here if the source is word, suppose our BX is a 16-bit register, then it is called as a 16-bit unsigned source. So we are taking here AX is equal to DX colon AX divided by unsigned 16-bit source. So we are storing the quotient in our AX register and we are storing the remainder in our DX register. So whenever we are performing the division instruction with the help of the 16-bit source operand, that time we are storing our quotient in our AX register and we are storing the remainder in our DX register. So you can write it as quotient will be stored in our AX register and our remainder will be stored in our DX register. So now we can write it as AX is equal to DX colon AX divided by our unsigned 16-bit source, that is our BX register. And now we can write dx is equal to dx colon ax mod of bx. So here we are storing the value of quotient in our ax register and we are storing the value of our remainder in our ax register. So I am writing here now ax is equal to dx colon ax divided by bx. So here we are performing the division of 16-bit by 16-bit number. So now in this example, for this example, we don't require this value, that is dx colon ax. This will be used whenever you have the number that is 32-bit by 16-bit of division. That time we are using the 16-bit for dx register and this 16-bit for ax register, and it will become 32-bit number. That time we are using that dx colon ax register. For this example purpose, we will take directly the value from our ax register. So our ax consists of 4445 divided by 1000. So after performing the division operation, you will get this value 4 as a quotient. So we can write it as 0004 and that will be stored it into our AX register. So this is our quotient and now we are storing the remainder in our DX register. So we are writing here DX is equal to DX colon AX mod of BX. But here our AX is 16-bit number and we have stored our first number, that is number 1, in our 16-bit register, that is our AX register. So we are taking here the value 4445 mod of 1000. So whenever you are performing this division instruction and where you are performing this division operation, that time you are dividing 4445 divided by 1000 and 10004 is a 4000 and you will get this 445 as a reminder. So this is your reminder and this is your quotient. So after performing the division instruction, you will get this 0004 as a quotient and 0445 as a reminder. So we are writing here is equal to 0445. And now we have to copy these contents in our AX and our DX register. So after performing the division instruction, this will be updated and it will store this 0004 and in our DX register will be updated with our reminder, that is 0445. So now you can check it here. Our AX will become 0004. So our contents of AH will be 00 and our contents of AL will be 04. So for reminder, we can store it as the contents of DH is equal to 04 and the contents of DL is equal to 45, that is 45. Now we have to call this DOS interrupt with the help of these two lines. So we are copying the contents of 4C into our AH register. We are calling here the DOS interrupt for terminating our program. And with the help of integer 21H interrupt, our program will be ended. With the help of end of the segment, we are closing all this data segment and the code segment. And with the help of end, we are terminating our program. So here in this program, we have checked how we can divide the 16-bit number by 16-bit number. And this operation will be used for performing the 16-bit number by 16-bit number. So keep in mind that whenever we are performing the division instruction and we are dividing the 16-bit by 16-bit number, then first of all we have to check what is the source operand. So here in this example, our source operand is BX register and it is the 16-bit source. And whenever we are performing the 16-bit by 16-bit number division instruction, that time our source will be 16-bit. And that time we are storing our quotient in our AX register and we are storing the remainder in our DX register. Now we will check this output in our emulator screen. So now you can check that our program execution will begin and it will be started from the dot code segment and we are initializing here these two lines for initializing our data segment. So this contents of address of our data segment will be copied into our AX register. Then we are copying the contents of AX into our data segment, that is in our DS register. So now we have to clear this AX, then BX and the DX will be 0000H. Now we are copying the contents of number 1 into our AX register. So see here our AX becomes 4445. Now our contents of BX will be 1000. Now we are performing the division instruction, that is division BX. So whenever we are performing this instruction, our quotient will be stored in our AX register, that is 0004, and our remainder is that is 0445, that will be stored in our DX register. And with the help of this integer 21H and MOVH, 4CH, we are terminating our program by calling the DOS interrupt into our AH register. So see here the value of AH will be 4C and we are calling here integer 21H to terminate our program instructions. So in this video, we have learned how to write an assembly language program to divide 16-bit by 16-bit number. And you have to remember 2 points, that is after performing the division instruction, the quotient will be stored in our AX register and the remainder will be stored in our DX register.